Hello gems, welcome to another video of ACE series. In this video we are going to discuss previous year BITSAT questions from the chapter of kinetic theory of gases. Okay, so if you're new to this channel, go check out the description box, know more about ACE series. Also, I'll be reading your comments at the end of this video, so stay till then and give me some watch time. So alright, question 1, 2 and 3 from the super easy category. In question 1, you are asked real gas behaves as ideal at, okay? P stands for pressure, T stands for temperature, arrow up means high, arrow down means low, okay? So low pressure, high temperature, low pressure, low temperature, high pressure, high temperature, high pressure, low temperature. Okay, quite simple. Actually, you should know this answer as a fact. Okay, real gas behaves as an ideal at low pressure and high temperature. Okay, remember this answer as a fact. I can convince you about this using one of the postulates of kinetic theory of gases. Kinetic theory of gases says that there is no force of interaction, there is no intermolecular force between any two molecules of an gas, okay, and kinetic theory is applied to ideal gas, right? So for a real gas to be an ideal one, there should be no force of interaction, right? No force of interaction among its molecules, okay? So and when will that happen? That will happen when the pressure is low. So the molecules are not squeezed in, they are spaced out, right? Pressure is low, molecules are spaced out, okay? You can imagine it that way, okay? So molecules are spaced out means there is large distance between them, a negligible force of interaction, also high temperature. Now if you know, kinetic energy is directly dependent on temperature, right? Kinetic energy is directly proportional to temperature. Higher the temperature means more the motion, less the interaction, of course, right? So low pressure, high temperature, okay? And remember this as a fact that real gas behaves as ideal at low pressure, high temperature. Over to the next question, question 2, okay? So in this question, question 2, you are given the ratio Cp by Cv equal to 1.66 and you are supposed to predict the kind of gas, okay? This was asked in 2018. Again, very simple, because we know that this Cp by Cv, we denote it by a letter. Remember, it is nothing but gamma, and gamma for a monoatomic gas is 1.66. So all we have to do is search for a monoatomic gas among them, right? So gamma value is given to be 1.66. We know that gamma of monoatomic gas is 1.66. All we have to do is search for a monoatomic gas. This is diatomic, this is monoatomic, okay? And this is poly, right? And other some more data, okay? Gamma of diatomic gas is 1.4 and gamma of your polyatomic gas is 1.33. okay? Or some of you might remember it in this format, that gamma is 1 plus 2f, okay? And you will remember the degree of freedom for monoatomic, diatomic and triatomic and derive this value of gamma from here, right? You will know the value of f for mono, dia and poly. You will plug it over here and get the value of gamma. I have no issues with it, okay? Remembering this value makes the question easy, okay? Anyways, over to the next question. Relationship between gamma and f. This one, right? Relationship question. We all suck at it. Anyways, we have it over here. You can see the relation between gamma and f. Gamma is the ratio Cp by Cv. F is the degree of freedom. But the only difference over here is that they want f in terms of gamma. Here we have gamma in terms of f, right? Gamma equal to gamma is in terms of f. They want f in terms of gamma, right? So just convert that form to and bring it in this format, right? Gamma f in terms of gamma, okay? So gamma minus 1 equal to 2 by f, bringing that minus 1 to this side, and now take the reciprocal or crisscross, okay? Crisscross, you'll get f equal to 2 upon gamma minus 1. F equal to 2 upon gamma minus 1. Option B is the correct choice. Quite a simple one, right? Over to the next question, okay? I hope all of these are clear, okay? Let's move to the next questions now. Okay, so question 4 and 5 over here. In question 4, you are given that kinetic energy of O2 gas, which is maintained at temperature T, is 0.048. You are supposed to find the kinetic energy of N2 gas, which is maintained at the same temperature. Okay, you are also provided with their molar masses. It's quite a conceptual one, because kinetic energy, okay, first of all, you try it. The correct choice should be, the correct option will be option C, right? Option C is the correct choice, because if you see, kinetic energy only depends on temperature. Okay, kinetic energy only depends on temperature. Okay, since both of them are at the same temperature, they will have the same kinetic energy. What is the formula for kinetic energy? First of all, it is 3 by 2 into RT, right? If you see kinetic energy, 3 by 2 is a constant, R is a constant. Kinetic energy only depends on the temperature and not the nature of gas. Okay, so both of them will have the same kinetic energy, which is 0.048. Okay, you can see it from here. Kinetic energy only depends on temperature. Remember that. Now similar question was asked in 2008. You were asked for the ratio of kinetic energy of H2 and ratio of kinetic energy of H2 to kinetic energy of O2 at a given temperature T. Since they are maintained at the same temperature, they will have the same kinetic energy, which means the ratio will be 1:1. Same, right? Both of them will have the same kinetic energy. So conceptual one, remember the takeaway point is kinetic energy only depends on the temperature. Over to the next question. So question 5 over here, again from the easy category. In this question from 2014, you have a balloon which is filled with this much volume of HE gas, 1500 meter cube of HE gas. This is maintained at a temperature of 27 degrees Celsius and at a pressure of 4 atmosphere. Okay, now you change the temperature and pressure and the volume will also change, right? So temperature is changed to -3 degrees Celsius and pressure is changed to 2 atmosphere. Okay, you are supposed to find the new volume. Quite a simple question because it is as expected from BITSAT, a formula based question, right? So you'll use equation of states. I hope you know what that is. So P1 V1 by T1 equals P2 V2 by T2. Okay, this is called the equation of states. We are going to use it over here. If you don't know about this, you can apply PV is equal to nRT in the two cases and then take the ratio. Okay, same thing. So let's substitute. Now P1, our initial case is over here, P2 here. Okay, first case, second case. Okay, so P1 is 4 atmosphere. Okay, V1 is 1500 meter cube upon T1 temperature. Place it in Kelvin. 27 plus 273, that is 300, equal to P2. P2 is 2 atmosphere. Now no need to worry about those units, right? They will get cancelled on both the sides. Okay, so don't worry about the units. Volume in the second case, V dash, we want to find it. T2 is, place it in Kelvin, that will be 270, right? So this and this and this and this, 3 5s are 15, 4 5s are 20, or this and this will get cancelled. So 2 5s are 10 and 2700, right? 10 into 270, that will be V dash, which is 2700. Option D is the correct choice. Quite a simple one based on equation of state. Formula based question, right? Or those who don't know can apply, as I said, apply PV is equal to nRT 2 times equal number of moles, right? You'll apply P1 V1 is equal to nRT1, right? Number of moles does not change, right? P2 V2 is equal to nRT2. You'll take the ratio, you'll reach over here. Okay, anyways, over to the next question now. So question 7 from 2017, again a simple formula based. Okay, so in this you have 5 molecules with speed 5 with their respective speed 500, 600, 700, 800 and 900. Okay, you are supposed to find a relation between Vrms and V average. Quite a simple one, just find average velocity first and then find Vrms. Average velocity, I can see it over here, it will be 700, right? Okay, one thing you can do, you can add all these terms, divide it by 1 2 3 4 5, right? Divided by 5, add this and divide it by 5, that will give you the average. But I know that the average is going to be 700. Okay, I'll convince you. Here you can subtract 100 from here, that will be that will make this 700. Give this 100 to here. Okay, that will make this 700. So 700 700 700, and here you can subtract 200, right? Give this 200 to this one, this will make it 700, and 900 minus 200, 700, right? So the average is nothing but 700. Okay, now we have to find the RMS velocity, which will be under root of, square this terms and take their mean. Square this, oh my god, 500 square, 600 square, 700 square, or I can do one wise thing. Okay, I'll write it as 5 square plus 6 square plus 7 square plus 8 square plus 9 square. Okay, I can take that 100 common, right? I can take that 100 common. So 100, which is 10 to the power 2 squared, right? I just took that 100 common and it is squared, right? It is squared everywhere. Now divide this by 5, right? Root mean square velocity. So mean over here. Now solve this. It will be a hectic job anyways. So 25 plus 36 plus 49 plus 64 plus 81 divided by 5, and we can take this out of the root sign. That will make it into 100. Okay. Now this will, I know that 64 and 36 adds to 100, 100 and 149, 149 plus 81, that makes it 12, this is 12, 13, and this is 230, 230, and what is left? 25, right? This plus 25 will make it 255. Okay, so under root 255 divided by 5, of course. So 5 5s are 25, under root 51 into 100. Okay, so I'll give you a short trick to find this under root. Okay, the trick is, it's a life hack. I learned it through my teachers, one of my teachers. So if you want to find the square root of this, one thing you can do is x plus y upon 2 root y. Okay, y is the closest perfect square to this number. X is this number, y is the closest perfect square to this number. This is a short trick. It comes from calculus. Okay, application of your differentiation, I guess. Okay, so yeah, you can use this instead of finding the square root manually. Okay, so x is this number, y is the closest perfect root, which will be 49, right? Perfect root closest to this is 49. So 51 plus 49 divided by 2 upon under root 49, right? Under root 49, that will be 7. So this gives us, this will be 100, right? 100 divided by 2, that will be 50, 50 by 7. So just compute 50 by 7 and that will be your answer. Okay, this is approximate, okay, approximate, but good enough. Okay, so you can make this approximation if the number is very, very close to the root. Okay, here you can see 49 and 51, right? Just 2, the difference is just 2. Okay, make this approximation only when the difference is very small. Okay, let's do it now. So 7 7s are 49. This will give us 1. 7 1s are 7. Okay, 3 7 4s are 28. So you can see that the root 51 is 7.41, and that into 10 to the power 2 will give you 714, right? This is 714. Average velocity is 700. So average velocity plus 14 gives you RMS velocity, right? Average velocity plus 14, average velocity plus 14 gives you RMS velocity. So option B is the correct choice. I hope you like this. Actually, I did one more video on this. If you want to watch digital math, okay, that will help you in your BITSAT. I'll suggest it over here. You can also watch it later. I'll put that into the description box as well. Okay, so it's a very interesting thing. It might help you in your BITSAT as well. So over to the next question. No more promotions. So question 8 over here. In this question, you are given that Vrms of a molecule at 27 degrees Celsius and this pressure is 200 meters per second. You are supposed to find the Vrms at this temperature and that pressure. Okay. Seems simple, but it is a conceptual one. Okay, because Vrms first of all is given as under root 3 RT by M, or I can just say that it is directly proportional to under root temperature, right? Vrms is directly proportional to under root temperature. Also, there is a relationship between Vrms and your pressure, which is under root 3p by rho. But does Vrms depend on pressure? Okay, it does depend. Honestly, it does depend, but the relation is complex. Okay, the relationship among them, among Vrms and 3p, is complicated. Okay, so whenever you are given a choice between temperature and pressure, only consider the temperature factor. Okay, mark my words, whenever you are given a choice when we are speaking of VRMS, whenever you are given a choice between temperature and pressure as a factor, only consider temperature as a factor. Why is this relationship complex? Because if you see, if you change the pressure, the density will change as well, right? So the relationship is complex. You can't say how will VRMS depend on that P. Okay, so we are going to only consider the temperature factor. Okay, so the takeaway point, if you're given a choice for VRMS, VRMS that it depends on temperature and pressure, only consider the temperature factor. Okay, here from here you cannot say that VRMS is directly proportional to under root P. This is wrong, because as you change pressure, the density will change as well. Only consider the temperature factor. Okay, that's all. So let's solve it now. VRMS 1 upon VRMS 2 equal to under root T1 by T2, right? Under root T1 by T2. T1 is at 273. Place it in Kelvin. Okay, at 273, 100 more, right? So 4. Okay, now VRMS 1, we know it as 200, so 200 into under root 400 is 20, or I can cancel this, right? Under root 4 is 2 and divided by root 3, that will give us VRMS 2. So VRMS 2 is nothing but 400 divided by root 3. Okay, option B is the correct choice. So only point was focus only on the temperature factor. Over to the next question. I hope this point is very clear. You can put that down in your notes. Okay, focus only on temperature factor. Over to the next question. So question 9 over here from 2016. In this question you are going to learn something new, so pay attention. So in this question you have 1 kg of 1 mole of a diatomic gas. Pressure is as shown. Density of gas is also given. You are supposed to find the energy of motion. Might seem quite simple because you know that kinetic energy is 3 by 2 RT or 3 by 2 PV. Okay, you can use this, and in place of volume you'll use volume is equal to, or density is equal to mass by volume. So volume is equal to mass by density, right? So you'll substitute the values over here. All values you can see over here: density, pressure, mass also is given. Okay, you'll substitute all the values over here, and the answer that you'll get is option D, which is unfortunately the wrong answer. Okay, so where did we go wrong? Okay, let me break your heart. Okay, so the thing is that, see, kinetic theory of gases is only applicable to ideal gases. No, kinetic theory of gases is only applicable to monoatomic ideal gases. Okay, now since it's mentioned in the question that you are beginning with a diatomic gas, don't use kinetic theory of gases. Okay, I know we use it here and there for for diatomic gases as well, but when it's mentioned in the question that it is a diatomic gas, don't use kinetic theory of gases. Okay, if you have some other approach, of course go for that approach. If kinetic theory of gases is the only approach, then you can apply it for diatomic gas as well. Okay, but here in this case we have another approach, which is law of equipartition of energy, which says energy equals NF by 2 into RT. Okay, now if you see for monoatomic gas, it becomes number of moles is 1. In this case it will become 3 by 2 RT, right? 3 by 2 RT, which is nothing but the same thing, right? 3 by 2 PV is equal to 3 by 2 RT, right? PV is equal to RT for ideal gas. Okay, so this is a special case of monoatomic gas. Okay, but we want it for diatomic gas. Okay, so we'll use NF by 2 RT. N number of moles is 1 in this case. F degree of freedom for a diatomic gas is 5. For a mono it's 3. So it gets back to the same formula, right? So 5 by 2 RT, we can replace it by PV, right? PV is equal to NRT. N is 1 in this case. Okay, so PV is equal to RT. So use P, and V, in place of V we can use M by rho. Now substitute the values. 5 by 2 into pressure 8 into 10 to the power 4 into mass. Mass is 1 kg divided by density is 4. Okay, I hope the units are balanced. Kg meter cube. Yeah. So 4 2s are 8, and the answer that we get is 5 into 10 to the power 4, which is the correct answer. Okay, so the takeaway point from this question was to use the equipartition of energy whenever it's mentioned in the question that it is a diatomic thing or a diatomic or a polyatomic gas, then use other approach. Okay, don't use this. Kinetic theory of gases is only applicable to ideal monoatomic gases. Over to the next question. So question 10 over here from 2011. In this question you have a liquid column of height h. At the bottom of this liquid column you have a air bubble of volume V0. Okay, this air bubble will slowly rise to the surface of this liquid column. Its volume becomes V dash finally when it just touches the surface. Okay, you are supposed to find that V dash. It is also given that atmospheric pressure is P. Okay, quite a simple one again, because we are going to use the equation or of states. Also it is given that temperature is constant. Okay, so you can see that process is slow, temperature is constant. We can also use P1 V1 is equal to P2 V2, isothermal process, right? We can use this, or you can use the equation of state, which is P1 V1 by T1 is equal to P1 P2 V2 by T2. Okay, and since the temperature is constant, T1 is equal to T2 and this will get cancelled. Right, so finally we get the same thing, P1 V1 is equal to P2 V2. Okay, so V2 is V dash, P2 is here. If you see the pressure acting on that air bubble is just the atmospheric pressure, right? So we'll write it as P. In case of 1, the pressure is due to atmosphere plus this air plus this liquid column, right? So P1 is P atmospheric pressure plus rho gh, right? Due to this liquid column, the pressure acting on this air bubble is rho gh. Okay, so P plus rho gh. Okay, so that is the pressure in the initial condition. V1 is V0. Initially the volume is V0. Now you have to find that V2, right? V2 is V dash. We have to find that V dash, which will be nothing but V0. Take this P in, it will be 1 plus rho gh by P. Okay, so that will be our V dash. So V0 into 1 plus rho gh by P. Option D is the correct choice. Over to the next question. So question 11 over here from the easy moderate category. Now congratulations if you made it this far. So in this question you have a container which contains 2 liters of water. You are going to heat this water with a coil which generates a power of 1 kilowatt. Okay, you are going to heat it from an initial temperature of 27 degrees Celsius till it reaches a final temperature of 77 degrees Celsius. Okay, the lid is open and you can see rate of loss of energy. So some energy is lost and the rate of loss of energy is 160 joules per second. Okay, this much amount of energy is lost per second. You are supposed to find the time taken in this process. Find the time taken to take the water from 27 degrees Celsius to 77 degrees Celsius. Okay, specific heat capacity of water is also given, right? Quite a simple one, because you are just going to first of all see power is rate of work, power is rate of energy, right? Q by T. Here the energy is heat energy. Okay, so I can write it as power into time will be heat, right? So you have to equate this heat, okay, the heat which is supplied by the coil minus the heat loss, right? Heat which is supplied by the coil minus the heat loss equal to the heat required to raise the temperature. I repeat that again. Heat supplied by the coil minus the heat loss equal to heat required to raise the temperature from 27 to 77 degrees Celsius. Okay, so heat supplied by the coil will be the power of the coil into the time T, right? For this much amount of time, this time it supplies heat, right? So power into time, that will give us the heat energy, heat. Okay, minus the rate of loss of energy, which is 160. Now 160 into this time, right? It is 160 per second. So 160 into whatever time it is, that much amount of energy is lost. Okay, that much amount of heat is lost. Now this will be equated to the heat required to raise the temperature. And what is that heat? That comes from the formula of specific heat capacity, right? So specific heat capacity is given as Q by M into delta T, right? So so Q equals MC delta T, okay? So this heat is the heat required to raise the temperature from 27 degrees Celsius to 77 degrees Celsius. So equate this two, right? So equate that over here, MC delta T. Okay, so power 1 kilowatt, okay, that is 10 to the power 3. I can take this T common, right? T common, this is 1000, 1 kilowatt minus 160, T is taken common, equal to M. What is the mass of this water? Mass is not given, volume is given, some extra data is given. So you are supposed to find the mass using the density, okay? Because you are supposed to remember the density of water, right? It is 10 to the power 3 kg by meter cube, right? So just use this relation, find the mass. Mass is equal to density into volume, right? So density into volume, 2 liters. So 1 meter cube, okay, is equal to 1000 liters. So 2 liters will be how much meter cube? That is, this is 1000 liters, okay? So 2 liters will be 2 into 10 to the power minus 3. Okay, so basically the same value, okay, same value. So 2 kg. So the weight of this water is 2 kg. So 2 into 4200 into delta T. Delta T, it will be same in Kelvin as well, right? No need to convert it in Kelvin and then find delta T, because change in temperature is same in both the cases, right? In Kelvin as well as in degree Celsius. So the change, you can see it directly in degree Celsius, that is 50, right? So let's just compute it now. So here we'll get 840, I guess. So temperature equals, this will become 100, 4200 into this becomes 100 upon 840. Wow, this is half, right? Exactly half. This and this will get cancelled. 42 divided by 84 into 10 to the power 3. So half, right? So 0.5 into 10 to the power 3, that makes it 500 seconds, right? So I can divide it in two parts. The answers are given in minutes. So divide it in two parts, 480 plus 20, right? 480 divided by 60 is 8, right? Divide this by 60, it's 8. So 8 minutes 20 seconds. 8 minutes 20 seconds is the correct choice. Okay, just summing up the process, the basic idea was to equate the power supplied by the heat supplied by the coil minus the heat loss, okay, heat supplied by the coil minus the heat loss equal to the heat required to raise the temperature. Okay, so then we substituted that and then we found the time. Okay, then basically solving it, right? And one logic we used to find the mass, right? Mass is equal to density into volume. Over to the next question. So question 12 over here from 2018. In this question you have a H2 molecule which is moving with a speed of 10 to the power 5 centimeters per second. Mass of that molecule is given in grams. The number of molecules that are going to strike this surface per second is given over here. Okay, so these molecules are going to strike at an angle of 45 degrees with respect to the normal to the surface. You can see that, and also they strike an area of 2 centimeter square. Okay, you are supposed to find the pressure. Quite a simple one if you know the derivation. There is only one derivation in this chapter, right? And you are supposed to know how to approach that derivation. You are supposed to know the steps of that derivation. Okay, so I'll summarize the steps. The step is to first of all find the change in momentum. Okay, find the change in momentum of one molecule, multiply it by the number of molecules, you find the total change in the momentum of all the molecules. Okay, then divide it by the time taken for the change of momentum. So rate of change of momentum is nothing but force, right? dp by dt or delta p by delta t will give you the average force. Okay, once you find the average force, divide it by area, right? Force per unit area is pressure. Okay, so simple steps over here. first find the change in momentum. Okay, so the molecule first, for only one molecule we'll consider. Okay, so the molecule is moving with a speed of 10 to the power 5 centimeter per second. It will strike at an angle of 45 degrees Celsius. Now you can see that only the x component will change, right? You can first of all resolve this velocity as 10 to the power 5 by root 2. Okay, 10 to the power 5 into cos of 45, right, which is 1 by root 2. Again 10 to the power 5 into sine of 45, which is 1 by root 2. Okay, so that is how I get the resolved form. Now you can see that only the x component will change, right? It goes and strikes the wall, only the x component will change. There is no force acting on the y direction on that molecule, right? The only force is acting is in the x direction, right? Only force, reaction force, is acting in the x direction, right? So the change in momentum will be only in the x direction. You can see that. And since the collision is elastic, let's consider this as the initial velocity, right? In x direction, this is the initial velocity. Final velocity will be the same, but the direction will be changed, right? Final speed will be the same, the direction will be changed, right? It will come back with the same speed. Okay, so we can say that the final velocity is 10 to the power 5, or we can say that we will consider this direction as negative and this as positive, towards us positive. Okay, this is negative, initial is negative, final is towards us positive. Okay, 10 to the power 5 upon root 2. Okay, so final velocity has just changed its direction, okay, towards us positive. Now find the change in momentum. That will be delta P equals m into V final minus V initial, right? Mass of one molecule, this much, 3.32 into 10 to the power 24. Now this is in grams. Let's convert it to kg. Okay, converted. Now V final is this thing, 10 to the power 5 by root 2, minus of minus, right? Minus of minus 10 to the power 5 by root 2. So that will become 10 to the plus, right? Minus into minus of the formula and minus of this will become plus, and you'll get this, right? So this is the change in the momentum. Now multiply it by, second step was multiply it by the number of molecules, right? So multiply it by this, 10 to the power 23. Shall we solve this? So this will get you 3.32 into 10 to the power 23. This is 5, and that is this will get us root 2, right? This will add to 2 into this plus this, x plus x, 2x, right? 2 into 10 to the power 5 by root 2 into 10 to the power 23. This will give us 28. 28 minus, this is 10 to the power minus 27. Okay, so here we have 3.32 into, this is 10 to the power 28, and you'll see that it becomes 10 over here, right? 10 to the power plus 28 minus 27, so we'll be left with 10. Okay, this 2 and root 2 can get cancelled, and you'll get root 2. Okay, so finally what you get, 33.2 into 10 to the power into 10 into root 2, sorry. Okay, now first of all, the speed was in centimeters per second, right? I didn't convert it, so I have to multiply it with another 10 to the power minus 2 just to convert centimeters with meters. Okay, just to convert this centimeters per second to meters per second. Okay, now I multiplied it by the number of molecules. What is the next step? Next step is to find the rate of change of momentum. Now we know it is for per second, right? So per second divided by 1, so no difference. Now we found the rate, that will be the force, right? dp by delta p by delta t is the average force. So this is the average force. Now we want pressure. Okay, so this is the force. Okay, this is the force for 1 second. Now we want pressure, so quite a simple job, force by area, right? Just divide that by area. So 33.2 into root 2 into 10 to the power minus 2 divided by 2. Okay, just solve this. Forgive me for any calculation error. The concept is 100% true. The steps are quite simple. First, find the change in momentum, multiply it by the number of molecules, divided by the time taken for the change in momentum. that will give you the force per unit area gives you the pressure. Okay, then you are supposed to solve this. The answer after solving you'll get is, I guess, 2350. Okay, just correct me if I'm wrong in the comment section. Over to the next question. So question 13 over here, this is the mixed type of question wherein you mix two gases, right? So here in this question you have mixed 3 moles of an ideal gas which is at a temperature of 27 degrees Celsius to 2 moles of a gas, an ideal gas, which is at a temperature of 227 degrees Celsius. Okay, you are supposed to find the temperature of their mixture assuming that there is no energy loss. Okay, some of you might directly know the formula that N1T1 plus N2T2 upon N1 plus N2. Go ahead and apply it. You will get the correct answer, but I'll just show you the way, okay, how you are supposed to derive it. That formula is only true if there is no loss of energy. Okay, so you can go ahead and apply that. So first of all, how did we reach there? So we use the conservation of energy. So let's conserve energy first. Here, what is the energy of this gas? It will be 3 by 2 RT1, right? 3 by 2 RT1. Okay, and the energy of the second gas, this is the energy of first gas. Energy of second gas, now it is 3 moles, right? The number of moles is 3, not 1. Okay, so multiply it by 3 and here you will get 3 by 2 RT2 into number of moles. Okay, so we use that relation 3 by 2 RT, the kinetic energy one, if you remember. Okay, and into number of moles, of course. Now nothing is given, so we can consider it as a monoatomic gas. Okay, so you can see 3 by 2, right? Degree of freedom 3 by 2, n F by 2 into RT. Okay, anyways, the final energy will be U1 plus U2. Okay, energy is conserved, right? There is no loss of energy. So U final equals U for the energy of the first plus energy of the second. Okay, now one thing that you have to keep in mind is that when you mix two gases, the thing that adds directly is their number of moles. Okay, basically mole is a number, right? So if you add 5 plus 3, it will become 8, right? It won't become something less or something more or something fractional, right? Mole is a number. So when you just mix two gases, their number of moles just add up. Okay, so the number of moles in the final condition will be 5. Okay, you're getting my point? Number of mole is a number, right? Basically mole is a number, so it directly adds up. Okay, when you mix two gases, the number of moles, number of their respective moles directly adds up. Okay, so here we can write NF by 2 into R. So n number of moles, 3 plus 2, 5. Okay, so N final equals N1 plus N2. Okay, so N F by 2, let's consider it as monoatomic. 3 by 2 into R is a constant, into temperature of the mixture. Now this is the mixture, right? Finally we obtain a mixture. Let's substitute this over here. 3 into 3 by 2 R T1 plus 2 into 3 by 2 R T2. Now you can see that result over here. You can cancel 3 by 2, 3 by 2 R, 3R by 2, 3R by 2, 3R by 2. You'll get 5 into temperature of mixture equals 3T1 plus 2T2. So temperature of mixture is, now substitute the values. 3, here you can see N1 T1 plus N2 T2 upon N1 plus N2, right? This will go down. So N1 T1 plus N2 T2 divided by N1 plus N2. So that was the formula way of doing it. Anyways, now T1 is 300, place it in kelvins. 2 into T2, now 200 more, so 500 upon 5. Okay, so 900 plus 1000, 1900 divided by 5, 5 3s are 15, 15, and you'll get 4, 5 8s are 40, 40, and yeah, 0, right? 5 8s are 40, 5 3s are 15, 16, 17, 18, 19, 5 8s are 40, and yeah, it should be a 0. Let's find this. This is in Kelvin now, right? We want it in degree Celsius, so minus 273. So that will give us 7, 10. So there 10 minus 3, 701 107 Celsius. Okay, 107 degrees Celsius is the correct answer. Remember this formula. T temperature of mix is N1 T1 plus N2 T2 upon N1 plus N2. And also remember that number of moles of two gases when they are mixed just add up. Okay, this is applicable only when there is no energy loss. Over to the next question. So question 14 over here, again you have mixed some gases over here. You have mixed 4 moles of hydrogen gas with 2 moles of helium and 1 mole of H2O or water vapor. Okay, this was asked in 2008. You are supposed to find the Cp of the mixture, the specific heat capacity at constant pressure of the mixture. Okay, so simple one, if you know the formula, I'll write the formula. You are supposed to arrive at this formula. So the Cp of the mixture is given as N1 Cp1 plus N2 Cp2 plus N3 Cp3. This can go on till n terms if we have mixed n gases, and that will be divided by the total number of moles, which is N1 plus N2 plus N3. Now, how will you arrive at this? It is quite simple. We'll just use the previous approach, the approach that we used in the previous question. So you'll use U1, U2, U3 over here. So you'll just add U1, U2, U3. Okay. How is U defined? U is Nf by 2 into RT. Okay. So you are going to find the energy of this and this. Add their energies equal to the heat required to raise the temperature by delta T, which will be Ncp delta T, right? Ncp delta T. The temperature difference is same in all the 3 cases. It was given, okay? And then remember one thing, that the number of moles in the final mixture, right? Number of moles in the final mixture just add up, okay? So the final N final will be just the sum of N1 plus N2 plus N3. Okay, so these 2 things you are going to use, equate the sum of their energies to the final energy or the heat required to raise the temperature by delta T. T is same in all the cases, so you can cancel out 3 T throughout, sorry, okay, and then final number of moles is N1 plus N2 plus N3, okay, and that is how you will arrive at this, okay. Now let's just substitute the values and find the answer. So N1 is 4. Okay, now Cp, there is a formula for Cp which is F by 2 plus 1 into R. Okay, F by 2 plus 1 into R is the formula for Cp. Okay, I hope you know that. If you didn't knew this, then note it down today. Okay, so F by 2 for a diatomic gas, F is 5. So it will become 5 by 2 plus 1, which is 7 by 2 into R. Okay. So that will give us 7 by 2 into R, plus here we'll get 2 moles of He. He is monoatomic. So here we'll have 3 by 2 plus 1, which is 5 by 2 into R, plus now 1 mole of H2O, that is polyatomic. Polyatomic, we plug in a value 6 over here, right? So 6 divided by 2, right? 6 divided by 2, that will give us a weight. In monoatomic, it is 3, polyatomic 5, diatomic 5 and polyatomic 6, right? 6 divided by 2, 3, 3 plus 1, 4. Okay, so 4R will get over here, divided by the total number of moles, 4 plus 2 plus 1, 4 plus 3, 7, right? So you'll get 14R plus 5R plus 4R divided by 7. Okay, so you can see that 14 plus 9, that will be 5, that will be 6 plus 3, 23. 23R by 7 is the correct choice. Okay, option D is the correct choice. This was the last question. I'll give you your homework question now. Read some of your comments and then hopefully we'll take a leave. Okay. So question 15 over here, this is your homework question. I'll just explain you what the question says. So in this question, you have 2 containers A and B. So in container A, you have gas A. In container B, you have gas B. So volume of the first container and pressure due to the gas is given over here. Okay. And volume due to the second volume of the second container and pressure due to the gas B is also given over here. then you connect these two. Initially they are kept separated, okay. Afterwards you connect them two with a rod or with a pipe of negligible volume, okay. This pipe has negligible volume. You connect those two, and you are supposed to find the final pressure. In this case, when you connect those two, the pressure is going to change. You are supposed to comment down the value of the final pressure, okay. The correct answer will of course receive a heart from me. Anyways, I'll move off screen so that you can pause and take a screenshot. Okay, so that's all for today's class. I hope you enjoyed it. Now time to read your comments. First of all, thank you for all the amazing comments that you have made on a series. So some of the comments asked me whether this is enough. Is this enough for BITSAT? I would say no, this is not enough for BITSAT. You have to go ahead and practice more such type of questions, okay? So first of all, this is just to give you an idea of what BITSAT is. You have to solve mocks. Mocks are an indispensable part of your preparation, okay. So this is not enough. This is just to give you an idea. Question 2 asked me whether these questions are actually BITSAT level, okay. So let me be honest with you, these questions are memory based BITSAT question, okay. So the level is almost same as that of BITSAT level. Now some of you all also requested for the semiconductor chapter, okay, do a video on semiconductor chapter. So let me finish with 11th standard first. Today we finish with thermal physics. Now we'll finish with the 11th standard. Only few chapters are remaining, and when we begin with 12th standard, probably we'll begin with the semiconductor chapter. Now some of you also requested for a BITSAT strategy video or BITSAT chapter wise weightage for each subject, okay. I actually replied yes to that comment, and now I realize that I suck at strategy, okay. So I won't be making any strategy video as such. You can go and check out some other creator, okay. There are piles of video on BITSAT strategy. You can watch it from any creator. I won't suggest any names over here. Anyways, that's all what the comments said. I hope you enjoyed today's class. If you haven't already, hit that subscribe button. I'll see you soon in the next class. Keep enjoying physics.